Yeah.
Yeah.
All right. So when we're determining the horizontal asymptote, which step is that?
Step 6.
No.
Wait, huh?
When we determine the horizontal asymptote.
2.
That's step 2.
Yeah.
Okay? So that's step 2. So what do we do in step 2?
In big over small, there isn't a horizontal path.
Big over small what?
Look at the lead coefficient, the degree of the. Wait.
Exponent.
Yeah. Degree.
Even more than that.
The degree of the exponent.
Even more than that.
The lead. The lead.
What?
The highest. The lead.
The highest degree.
The highest, the biggest.
Biggest
Coefficient.
degree.
No.
Exponent.
Biggest what?
Exponent.
Biggest exponent. So we compare the biggest exponent on top and on bottom. Okay? 3 choices are, or 3 possible outcomes are.
Big over small.
Big over small, what do we get? None. Okay?
Small over big.
Small over big. Let's talk about that one here first.
Y equals 0.
Okay? Love it.
And same.
When they're the same, what do we get when they're the same?
Compare the you compare the A and B. A over B.
A over B. And those we said, you guys just said are the lead coefficients?
Yeah.
Okay? Now that screwed up some people on number 2 on the quiz last week.
Some people.
I got a lot of 5/7 on the as the horizontal asymptote number 2. Okay? It's not the first number that you see on top and the first number you see on the bottom. It's lead coefficients. Okay? So you might have to do some reordering of stuff up top or up bottom. Okay? But today I want to focus in on this big over small.
Shall we write this
One.
down?
I would. I mean, I'm crazy like that, though. Right? And that we would normally get none for our horizontal asymptote. Yes, ma'am.
Do you recommend writing it on a little cheat sheet?
Not yet.
Okay. So
Like notebook paper.
I'll tell you what to put on the cheat sheet when it comes to cheat sheet time. Sorry. Supplemental
No
note.
sheet time. Do you have slight OCD?
Why?
Because you're always very specific about your colors and like writing things.
Every step is the same color?
Or it's like, yeah.
Very much so.
Visualize
And he does his fabrics.
And with fabrics, too. All right. So what we're specifically going to be looking at in the big over small case is we are going to specifically be looking at when the degree of the top is bigger than the degree of the bottom by 1. Okay? That is the specific case that we get. So if the degree of the numerator is 1 bigger than the degree of the denominator, we get a slant asymptote. Okay? So a slant asymptote is just that. It is an asymptote at an angle. So it's not vertical, it's not horizontal, it's skewed. That's the mathematical term for it. It is skewed. And it only happens, Tim, if the degree up top is 1 bigger than the degree on bottom. That's the only time that it happens. If it's 2 bigger, then we get a quadratic asymptote. And we don't want any of that. We want none of that. Right? Yes. Okay.
That's it.
So let's figure out, let's devise ourselves a plan of how we're going to find said slant asymptote. And it's actually a tool that you already have in your toolbox. You just don't know it yet because you just literally learned what a slant asymptote was. Okay? So what we do to find it is we just do the division.
Oh, yeah, division.
Oh yeah, exactly. Okay? We simply do the division.
Division, so
So let's say we've got this. F of x is equal to x squared plus 4 all over x minus 2. Degree of the top is 2. Degree of the bottom is 1. So we are in that slant asymptote case because the degree on the top is 2. The degree on the bottom is 1. So there's no horizontal asymptote, but they differ by 1. We have been ignoring the slant asymptote up to this point in time. And we haven't had any where we haven't had. Well, all of ours so far have had a y equals 0. They've been reciprocated, flipped, if you will.
So on this sheet, you don't even need to find the slant asymptote. Because it doesn't give us.
But if you want to graph it, you will. So, the first step that you're going to do when finding the slant asymptote is you are going to do the division. Now, how you go about doing the division, that's totally and 100% up to you. You have two choices at your disposal. You have synthetic, where we can say x minus 2 is equal to 0, so x is equal to 2. The coefficients up top are 1, 0, and 4. Drop it like it's hot, multiply, add, done. Or you have long division at your disposal. X Agree? So you have either way. And to me, it doesn't matter which way you do. So you got that. Alright? So that's step number 1. You're going to simply do the division. Now, in all cases, if you have a slant asymptote, you will have a remainder in your division. Because if you don't have a remainder, then you missed step 0. You missed the factoring step. Something would have factored out. Okay? So in all of these steps, you will have, or in all of these slant asymptote problems, you will have a remainder. And step 2 is just that. It deals with the remainder. You're going to drop the remainder. You're going to forget about it. One might say you're going to drop it like it's hot. Yes. Okay? So you're just going to forget about it. You're going to just cross it out. Because when numbers get to infinity, it's like adding 0 to the problem. And those are really the only 2 steps to getting a slant asymptote. So those are the really only 2 steps about getting a slant asymptote. And so then we just have to write it then. We can shorten it up to just SA for slant asymptote. And it's going to be in the form y equals, oops, I forgot the x, mx x plus b. So in both of these cases, the slant asymptote here would be y equals x plus 2. Now, that leads us to step 6, which is now what we can fill in on our supplemental sheet. So we would want to say numerator is 1 degree bigger than the denominator. That's our one classification. Numerator is 1 degree bigger than our denominator. That tells us we've got to find the slant asymptote. How we go about finding the slant asymptote, the first thing we do, we actually divide them out. Second thing we do, you've got this written down, we drop the remainder. Third thing, we write it in its proper form, y equals mx plus b. So remember, too, that when we put the slant asymptote on our graph, now it's going to be at an angle, so we probably want to have a ruler or an ID or something along those lines to make sure we get that on their straightness. It also goes on our graph dash, like our other asymptotes. So we've got those things in there. All right, let's do it. Here we go. Sketch the graph. Include any intercepts, asymptotes, and holes. Love it.
Love it.
F of x is equal to x squared minus 3 all over x minus 2.
That was horrible thing. Okay, this is so you can't look at me like that, like we don't joke around all the time.
Right into my soul.
You gotta talk about my free throw shooting though.
All right. So, step number 1. Or excuse me, pardon me. Whoa, tap the brakes. Step 0. Step 0. Okay, what do we got for step 0?
What?
Simplify factor. Can we simplify factor anything?
Well, I'm just saying, if you wanted to, could you just find the slant asymptote right away?
But we don't know that there is one yet because we haven't gotten to step 2 yet. If we're following our steps.
Well,
I know, I get it.
Okay.
I get it, but we're following our steps, so we do everything the same way every single time. Because not every single time is there going to be a slant asymptote. Okay?
So you got an
Right.
X.
So can we factor?
Yes. Yeah. Yes. Yes.
Yes?
Ross did.
Why not?
Yeah, but it's
You're
not
doing
working.
something wrong.
No, I don't think we can factor the top, because the top isn't a trinomial, and it's not a perfect square minus a perfect square. So yeah, so so step 0, done. Okay? Step 1 says what? Domain and vertical asymptotes. And how do I do that? Denominator equals 0. So that's x minus 2, set it equal to 0, x equals 2. So that gives me a domain of all real numbers, but x can equal 2, and it gives me a vertical asymptote of x equals 2. Okay? Now let's see if I can get this all into one. Then we don't have to be scrolling up, down, left, right, all over. Okay? So that gives me vertical asymptote x equals 2. Puts it right per. Yes? Okay. Love it. Step number 2. Horizontal asymptote. Degree on the top, 2.
It's one bigger than the degree on the bottom.
1, yep. So that's a none case for horizontal, right? Okay. So it's a none case for horizontal, but it's a none asterisk case because it's 1 bigger. So that means we have a step 6. Okay. Now, one thing I forgot to say is, because we didn't factor anything in step 0, do we have a step 5? No, because we didn't factor anything else. There's not going to be any holes in this. Okay? All right, love it. Step 3 we're on now?
No. Step 3, yes.
Yeah. Step 3 is find the y-intercept, right? Okay. What is my y-intercept? Somebody said it. 3 halves. Plug in 0. 0 squared is 0. Minus 3 is negative 3. Plug in 0. 0 minus 2 is negative 2. Negative 3 divided by negative 2 is positive 3 halves. That's 1.5 to you and me. What we've got there. Yes?
No.
No?
Yes.
Yes. Okay. Step 4.
Oh, that's it.
X-intercept, none?
Yeah.
Do we agree with there is no x-intercept?
No.
I don't agree with that either. What do we do to find the x-intercept? Negative, that numerator, so x squared minus 3 equals 0. How do you want to solve that? Add 3 gives me x squared equals 3. How do we want to solve that? Square root. X equals plus or minus 3. Do we agree with plus or minus 3?
The square root.
I like plus or minus the square root of 3.
So when's the imaginary thing coming in?
If we have an imaginary number.
So how do you know?
We take the square root of a negative number.
Oh, okay.
So that gives me an x-intercept at the square root of 3 comma 0 and 1 at negative square root of 3 comma 0. Now, to plot that on our graph, square root of 3 is how much? Y between 1.5 and 2. Isn't it? It's 2.25. Okay, right? Or square root of 1 is 1. Square root of 4 is 2. So it definitely has to be in between 1 and 2. And that's closer to 3 is closer to 4 than it is to 2. So yep, I would agree. So then that would put me here and about there. Ish. Right? We can just approximate. If you wanted to actually go to your calculator and get 1.713, okay, you could get 1.713 then, if you wanted. I get the 1.7 part. Because I know the square root of 2 is 1.414. Because back in my day, we had to just memorize things.
Back in your day.
And memorize the square root of 2 and the square root of 3 because they were so common. Yeah? Good with step 4. Step 5 now.
There is none.
None. None holes. That brings us now to our brand new step 6. How do we want to do set division?
Long division.
Synthetic?
Long.
Synthetic?
Long.
Synthetic is easier.
No, it's not.
That is.
easier.
Not when you have such a small problem.
Sheesh. So what am I dividing into? What's going to be my divisor?
2.
2, right? Because x minus 2 equals 0. It's up here in blue. Okay? It's that number. That number is going to be divided into it. Okay? On top, my coefficients are 1, 0, and negative 3. 1, 2, add, 4, add.
Now it's time to get rid of those remainders.
Get rid of the remainder.
And then you got x plus y equals x plus 2.
Y equals x plus 2. Agree with that, Roz? Okay, I just wanted to make sure. Did you have a question on something else? I don't want to go too fast. If you have a question right here.
Oh my god.
When I told
The
them,
driving like it's hot guy.
I asked them, I said, why
He's
is
complaining
he?
because
Yeah.
Whoop, you're a horrible person.
Right? How, here's the question now, how am I going to graph y equals x plus 2 on the graph? Jenna?
You're gonna go up to like the y-axis, right?
Yep. Up.
And you're gonna go to like 2.
So up 2?
Yep.
Put a
And then
dot.
you're gonna go up 1, over 1, up 1, over 1.
What now? What direction is this overness?
Up to the
Right.
Up and right?
Right. yeah.
Okay. Up and right. Up 1, right 1, up 1, right 1.
How are we doing this?
This is our slant asymptote.
Is that right?
What if I didn't want to go up and right?
Try about it. Go
Down and left?
I don't understand that.
Understand what?
Can you explain?
What do you need to explain?
If it was just
How you
to
graph
be
that?
up.
How I graphed it?
Yeah.
Okay, because y equals mx plus b. B is my y-intercept. So 2 is my y-intercept. Okay, so from the origin I go up 2 and I put a dot. Okay, m, the coefficient on the x is my slope. This is 1. So 1 over 1 is a fraction. Up 1, right 1. Up 1, right 1. Up 1, right 1. All the way through.
Will we have a problem for
Yes. Okay, and then that goes on dashed, correct?
Sure. And we draw flower.
Yes? Okay, step 7.
No.
What's T-chart, okay? So left zone, we only have 2 zones on this one, right? We got a left zone and a right zone.
Yeah.
Left zone,
You already have.
I got 3 points in my left zone, yeah.
Yeah.
a parabola?
Is that a parabola?
No,
Oh,
because it's not symmetric,
okay.
but it's kind of, okay?
Oh,
Now, Crayon asked a great question before. What was your question? Can we cross a slant asymptote?
Yes.
The answer is no.
Oh, come on, guys. Let's get it.
Wait, okay.
Mihol?
Uh,
Because we had the 3 points in that zone.
Yeah.
The 3 intercepts.
so
Yeah.
you just
I'm a
draw
little
your
behind.
draw your line.
Oh,
Wait, so why can't...
That line that you told me to draw, you got to draw that one.
I did that one. Don't
Oh,
worry.
okay.
So why can't it go through it?
Through what?
The essay.
Because it's one of those highly restrictive ones, like a VA. Yep. Okay. So then we just need to come up with points over here.
3.
3 is a good one. If I put 3 in, 3 squared is 9, minus 3 is 6. 3 minus 2 is 1. That would be 6. 2 and 4 and 6.
Will it always be in the other, like?
No.
of the slant down?
No. That's why we gotta try it. Then let's do 8. 8 squared is, wait, do I want to do 8? Or no, I want to do 6. Sorry. Yeah, I want to do 6 or 7. 8's off of my graph. Let's go 6. 6 squared is 36, minus 3 is 33. 6 minus 2 is 4. I get 33 divided by 4. 33 divided, a little more than 8, 8.25. Yep. Okay. So 4, 5, 6, 2, 4, 6, 8, a little bit more than 8, puts me there. And so then it's going to be here, and then yes, indeedly do. Questions, comments, concerns, more explanations.
Okay, you went too fast on the slant asymptote, and I didn't.
What part of the slant? The graphing part of the slant asymptote or the finding of the
I
equation?
know how to find it, but
Okay.
the graphing,
So y equals mx plus b. These are graphing lines like we did way back,
yeah.
second unit that we did. Okay, right? So this is 1x plus 2. Okay,
Oh, okay.
so my y-intercept is 2, so that's why we went up 2 and put a dot. Then because my slope is 1, that's 1 over 1, so that's up 1, right 1.
Got it.
And then we just keep doing that. Or we could go down 1 and left 1. And keep doing that.
Yeah, I had the same question last time.
I'm sure you did.
He actually did.
There will be a better place.
Better place with more flowers.
Wow.
Yeah.
Oh, I went the wrong way.
Yeah, I was
What
waiting.
in the,
I know I went the wrong way here. I was all excited I was going to draw a flower, and then I went the wrong way.
Oh,
That was a
flower.
fair flower. Is a dandelion a flower or a weed?
I don't know what that is.
That's a flower with multiple petals on it. All right, let's
Looks
get
like a fan.
it. Looks like something, all right. At one point in time, I followed it. I can do the hammer, but all right, go for it. Graph that bad boy. Siri. Good Lord, man. All right, here we go. Step 0 says that I need to simplify or factor. Okay? So this can become x minus 5 all over, or an x minus 1. That's a bad 5. We got to fix that 5.
It looks like a 6.
I know, it looks
That's
just
what I'm
looks
saying.
goofy. All over x minus 2. Yes?
Right.
Yes?
Did
Yeah.
I do it wrong from the beginning?
Yes.
We did it wrong.
We.
Wrong.
Did you have it right and then she
No.
convinced you otherwise?
No.
I had to have X.
Okay.
Yeah.
I
All right.
did this far.
Anything factor out?
No.
Nope, so we're good there, okay? So then, step number 1 says the domain is
The factory.
X can't equal 2.
x can equal 2 again, which means my vertical asymptote is
X equals 2.
x equals 2.
We're so close, but that's why you're upset. Okay, well, so now that holds the center. So it should be -5.
Yes?
Yep. Easy fix.
Okay. Hey.
Yeah,
No.
sorry. Yeah, stop. Not
Yeah.
easy fix.
Not what you said. Okay?
Oh.
Step number
3.
2.
2. Find the horizontal axis.
Degree of the top.
2.
2. Degree of the bottom.
1.
1. That's a 2 over 1.
Big over
That's a none case, right? But differs by 1, correct? So that's a none with an asterisk.
Oh, we have to put an asterisk on there?
Well, because that reminds you to say, oh, I got a slant asymptote. I got to do step number 6.
Okay.
Wait, do we have to put
Behind
an
that.
asterisk on the test?
No.
Okay.
intercept.
Where you substitute 0 and for x
0 squared is?
0,
6 times 0 is?
0,
0 minus 0?
0,
Or excuse me, plus 5.
5,
5. 0 minus 2?
0, so it's negative.
So that's negative 2.5? 2.5. Off to a good start so far. Love it. X-intercepts. X-intercepts.
5 and 1.
5 and 1, because I set the numerator equal to 0. So that gives me 5 and 1. Two, 3, 4, and 5. Very strong. Good on that?
Step 5, there's 0 holes.
No holes. Didn't factor anything out in step 0. Oops. I almost put no holes there.
So what's that?
Okay?
Step 6,
Step 6.
find SA.
Okay? So 2 is the number that I'm going to divide out, right? Or my 0, I should say. 1, negative 6, and 5 are my other coefficients. Drop, multiply, add, multiply, add, then drop the remainder. Talk to me.
No, I just was doing 2 times 2 or 2 times 1. Oh wait, no, I just
It happens.
Yeah, it's fine.
I'd rather have you make a mistake now than next week Wednesday.
Oh,
Or
that's
this
okay.
week Friday, for that matter.
Yeah, those are big deals.
By the way, side note, decided on summative this week.
You
Yes.
did?
Thank you.
When's the unit?
Friday and then Wednesday.
Okay,
Holy
so
crap.
on Wednesday.
So it's Monday.
You decided on
Review.
the summative?
Yep.
What's on Wednesday?
Oh, this
Yes.
is a shit.
Next week Wednesday, the unit test, because it's the day before break.
Wait, what Friday?
Not this week Friday, or next week. Okay, so this week Friday summative quiz.
Yes.
Next week Wednesday summative unit test.
Imagine having a
Oh,
formal.
so you just decided that this week is going to be somewhat of a self-formative.
No, the other class did.
Oh.
So we're just. Who decided it?
The people like me who need the summative grades.
Yeah, so you do bad on them and then.
I'm not going to do bad at them because I understand this.
You're being selfish.
Wow.
Captain last day.
Well, Roz, there's this thing called MRC.
Yeah,
you
that I
should check
visit
out.
there, a lot actually.
Good so far.
Why
For
does
my
it help?
free time minutes.
We're pretty solid.
Do we have a solid left side?
Yeah.
Yeah.
Yep, I would say so. Comes down from above. There and there. Okay. We just have the other side that we got to do. We already got one over there though too, right? So
Should plug in 3.
plug in 3. If I plug in 3, 3 squared is 9. Minus 18 is negative 9. Plus 5 is negative 4 all over 1. 1, 2, 3, and 4. There we go. Looks good. Comes in through here and shoots down like that. Looks good. Yes?
Yes.
Yeah.
Okay. I'll come back to it in a minute, but I want to get to this next slide here first. And that slide says that you can now do numbers 1 and 3 on this week's worksheet. Love it. Okay. But more importantly, I have a short video. It is 13 minutes. But the first half of the video is walking you through your supplemental note sheet to make sure you have everything written down the way it should be written down. Okay? So that's the first half of the video that you have to watch tomorrow.
Wait, why can't we do number 4? What's in number 4?
On 2 and 4? We'll get to them. Okay? So, and then there's one more example. Okay? So it's one example that I'm checking, and then I'm going to be checking your supplemental note sheets tomorrow, or on Wednesday too. Okay?
Oh, so